Yeah, good morning everyone. In the previous class, we have discussed about list. So list is nothing but it is an order collection of element. So the list can be implemented in the two methods. One is using array, other one is using linked list. So in the previous class, we have discussed about how the list is implemented using array. So the list using array, it has some disadvantages. So to overcome that disadvantages, we are using linked list. So the disadvantages of a list using array is during the insert operation and deletion operation, the values will be shifted. For example, to insert a new value into the already existing list, we have to insert a new element into the already existing list. So for that, we need to shift the element. First, we have to increase the size of the list. Then we have to shift all the element one step down. Then we can insert a new value. So this is insertion. So likewise for the deletion. So delete a new one value from the already existing list. First, we have to move all the values one step up. Then we have to reduce the size of the list. So this is the insertion and deletion of linked list using the array. So due to that, it will take much time. So to avoid that insertion and deletion time duration, we are using the linked list. So using this linked list concept, we can okay, the deletion as well as insert operation will take only less time comparing to the array. So now we will discuss what is linked list first. Okay, so next is, so this is the properties or features about the linked list. So the linked list means here it will be called as a node structure. So each node contains the two field. One is data field, other one is link field. Or you can say this is a pointer field. So the data field it will contains a value of the node, and then this link field it will contains the address of the next node. For example, in this example, the 12 is the first node, first value. So this address is, say for example, we can take the 100. So this 100 is available in the head node. And likewise, for this next field contains the address of 20th node. So this is a value of second node 20 and the address of this node is 200. For example, we can take this as a 200. So this 200 will be available in this link field. So this is the structure of linked list. So each and every node contains the two field. One is data, other one is link. The data field contains a value of that particular node and this address field contains the address of where the next node is available. Likewise, we can insert the value, no, insert the nodes one by one. So the end node, the last node contains only the data field. There is no address field because it is a null. Likewise, for the first node is called as a head node. It will contain only the address part. There is no data part. Usually, each node contains the two part. One is data part, other one is address part. But for the head node, it will contain only the address part as well as for the tail node, it will contain only the data part. There is no address part. So this is the structure of the linked list. Okay. So next we will discuss. So the using this linked list, the successive elements are connected by the pointers. So first we are creating one single node. So the next node will be created will be using the pointer concept. So the last element always points to the null. And also we can use a linked list. Here the linked list can be grow during the execution. We can reduce the size as well as increase the size during the execution. So that's why this linked list is one of the example for dynamic memory allocation. So dynamic memory allocation means during the execution time we can increase the size as well as reduce the size of the list. So this is the one of the best example of dynamic memory allocation, linked list. So it can be at the user how much node the user wants to create, that much we can create. Here there is no restriction. And also using the linked list concept doesn't waste any memory space. But in array, so we have to priorly define the size of the array. For example, the overall size of the array is 100, but I have used during my execution time only the 10 elements means remaining 90 spaces will be wasted in the array concept. But in this linked list concept, there is no wastage of memory. So whatever we are using the memory, the same will be utilized without wasting. So this is the advantages of linked list concept. So next, so these are the operation we are going to do in this linked list. First one is create operation, insert operation, delete, display, search, as well as delete with the using key. So creation means we are going to create a new linked list from the scratch, from this first node to whatever we want, we are going to create. So that is a create operation. Then next is insert operation. So adding a new element to the already existing linked list. Deletion means the user wants to delete any element in the existing list means we can delete it using the delete operation. Display means whatever the elements in the linked list that we can display using this display operation. And search or find operation. We can search any element in the list using a given key. So the user has to give an input as a key. So using that key, we can search that element whether it is present in the list or not. So this is the search operation. And delete also we can perform using a given key. The user is given the key as an input means that particular key element we can delete. So these are the operations we can perform in the linked list. So next. Yeah, how to create a linked list. So that we will discuss from the code. So wait, we will move on to the, okay, this is the structure part. Generally, to create a node structure, already I explained the linked list node means it will contain the two field. One is data, other one is pointer field. To create that, we are using the structure. Okay, here all the data structures are implemented using C language. In C language, we are going to use a structure to implement this linked list node. So here already we all know the node contains the two field. One is data field, other one is pointer field. So here we are creating one node structure. So here the definition, the syntax for the structure is struct node, and inside the structure we are creating in two members. One is data, it is an integer, and next one is a pointer. So we have to define with the data type. Here the data type of the pointer is struct node. So struct node star next. So this is the self-referential pointer. So already we have discussed what is self-referential pointer. So this pointer points to its own structure. Here in linked list, so always the here in this example, wait a minute. Yeah. So here the linked list means here the 12 is the first node, and then here this next the link contains the address of the 20th node. So this is the pointer. Okay, this pointer points to its own structure. Again, the structure like its own structure. So that's why it is called as a self-referential structure. So next. Yeah. So for this, we are creating a structure of the one linked list node. So the node contains the data as well as a pointer that we have created. So next here, we just created a structure, not the memory. So now this linked list on dynamic memory concept. Now we are going to create a memory space in the heap. Okay, so here the dynamic memory means all will be created with the pointer concept. So now we are creating an object for this accessing a structure member. To access the structure member, we have to create a object. So here we are creating object as a pointer. So struct node is a data type along with user defined data type. Here we are creating the head as one object and the next is a pointer is another object. Okay, so here for this PTR, we are going to create a memory in the dynamic memory, that is heap. So for that, already you all know what is malloc syntax. The malloc is nothing but it will create a single block of memory in the heap. So here we are going to create a node structure using this malloc function. So for that, here we are taking one pointer PTR, and then the data type is struct node asterisk malloc, size of the struct node star node asterisk. So now the memory will be created for this node structure. So first we have created the node structure, then followed by we have created an object, and here we have created a memory space for this particular node. So now one node will be created. Then we are going to insert the element into that node. So that we will discuss, right? Okay. So this is a head node, initial node. Initially the head contains a null value. Then we are creating a structure for this node, individual node. The node contains an element as well as a pointer. There is a next field. Either the element is a roll number, name or age, and here the address of the next node. So this is one single structure is created using the structure as well as the memory malloc. So the structure is created along with the memory space also created in the heap. Next. Yeah. So likewise, we can create a node. First head node, it points to the first node because this A address is available in the head. Likewise, this B address is available in the next field of A. Likewise, the C address is available in the next field of B. So this dot is called as the next field of the next node. So the B address is available in this field. Likewise, etc., etc. We can create a node. Wait, I will directly go to the syntax for here creation. Wait. Yeah. So first we will take this how to create a node structure. We will discuss with the programming. So here the node structure. Already I told you the node is nothing but it contains the data field as well as next field. For this we have created a structure. So struct node int of data, and then here the structure contains the two field. One is data field, other one is the pointer field. So both will be created using one structure. So now the node structure is ready. Then we are going to create a memory for our node using the malloc function, and this structure will be accessed using the objects. So here we have to create an object with the user defined data type struct node asterisk head as well as here the new node. So in the previous example I have I showed the PTR. Instead of the PTR, here to understanding purpose we are creating this as a new node because we are going to create one new node structure. So here the new node. So next is we are wait. I will tell you what is the choice of this later. Now we will discuss. So this okay, not a new node. Here is also it's a PTR, not the new node. Yeah, wait a minute. Sorry, not PTR. It's a new node. Yeah. So now the new node. Wait. Yeah. So now we have created the memory for the new node. New node equal to struct node asterisk malloc size of struct node. So our new node is created initially. So now I have created this structure node along with the data field and next field with the memory. So I have created this memory for this node. Next, I am going to insert the element data to this data field and inserting some address to this field. So initially the head pointer contains the null value because the head always contains the address of the first node. Now only I am creating a structure of the first node. So now this address will be stored into the head. So before that initially the head contains the null value. There is no address in the head. So head equal to null initially. That's why this line head equal to null. Now, okay, after the head is assigned as a null, I'm going to enter the element of this data field. For that, you have to use the printf statement, enter the element and get the value from the user, which value the user wants to enter. So scanf percentage comma new node. So we cannot directly access the data because this data is on structure member. So you have to call this member along with its reference. So here reference is and pointer. So new node, arrow operator and data. So using this one, the arrow operator only we can access the member. Otherwise, we cannot use the member directly comma data. So if comma data means there is no value for this data. So we have to access this data through the arrow operator with the pointer. So new node, arrow operator and data. Okay, so this arrow operator for the you have to create using the minus sign with the greater than symbol. So while typing the code. Okay, so now we got the element from the user. Next, so now in this data field, I have inserted some element. For example, some file. Okay, some file is inserted here. Okay, wait a minute. Yeah, wait. Yeah. For example, so I have inserted some file input. I collected the input from the user file, the data that I have inserted here. Now the value is inserted. This is the first node of my linked list. Now, so we here this next is this is the first node means there is no next element. There is no next node is available in our linked list. So this is the first node. So definitely the next field is initially null for the first node. That's why here the new node next equal to null. So null means is zero. It contains only the zero. So no new value. Wait a minute. Yeah. So next is this. Wait. Yeah. So here some zero. Okay. Yeah. So in this field, next field is 0. So now we have inserted data as 5 and then the next field is null. New node next is equal to null. Next, so now we have created successfully one new node, and then we have inserted the data, and then we have mentioned the next field also is a null. So now I'm going to insert a second node. Okay, for example, I'm going to insert, okay, this head along with the 5 and 0 is created. Head is pointing this, okay, and this node address is, for example, this node address is 100. Okay, so this new node address is 100, so that address 100 is okay holded by the head. So now the head is equal to holding the address of 100, so this will be connected. Okay, the head is along with this, here the 5 is available, here 0 is available, so the first node is successfully created. Next, I am going to create a next node, second node in my linked list. The first node is created with the address of 100, so this 100 is holded by the head. Now I'm going to create a second node. So how we have to connect with the second node with the already existing list. So already existing list contains only one node. So now we are going to insert a second node. So for that again you have to, okay, already we have created a structure, and for that structure the memory is also allocated. So now the new node structure is created with the malloc function. Now, as usual, you have to get the value from the user, enter the element. So the element is some value. So now we are going to get, wait, I'll take some. Hmm. So now I'm going to insert a second value. So some 10. Okay. So here this for the second node, I have created a 10, and then the address of my second node is, okay, the data is 10, data equal to 10, and then address of my new node is add of new node is some 200. So now the structure is created with the new node. This is our new node now. So the data field is 10, and then this new node address is 200. So now we how we have to connect this. So this already existing list next is contain the null value. Okay, now how to connect with this null with this new node address, that is 200. Now we have to replace this 200 into this field, next field. So how to replace that? For that, first we have to check one condition, whether if head equal to null or not. If head equal to null means the newly inserted node is the first node of the linked list. But in our case, already we have inserted one new node, but we are inserting a second node. So this case is not true for us. If head is equal to null, is a false case. If it is head is equal to null means directly you can assign head is equal to new node. So that is the first case we did already. Okay, directly assign head is equal to new node means the new node address 100 is stored into the head. So the head and new node is connected. But in the second case, we are inserting the second node. So in this, for this second node, so first we have to check, okay. So else case, the true if case is false for this second node insertion. So next we have to go for the else part. So in this else part, the head next. So this is a head node. Okay, this is called as the head node next field. The head node next field is null already. That's why here we have given the next new node in next is equal to null. Now this is a null. In this place, we are going to replace this 200. So for that, we are using this new node addresses. This new node address is 200. So that new node means here it will be called as a 200. So this 200 is assigned to the head next. So this is a head next. So now this 200 new node address is assigned to the head next. So now this place is 200 means automatically our second node with the data of 10 is connected, and then this new node next is equal to null. Okay, so now this new node, this is our new node, this new node address is 200, that will be given to the head next. So the head next holds the address of 200 means automatically these two node will be connected now. And now already we have entered the data also 10 here. Now this new node next is null. As usual, our condition new node initially after creation of every node, the next field is initially null. So that's why here the new node is null, and then this new node is given to the head next. So that's why head next equal to new node. Okay, so now we have inserted the second node successfully. So head pointing to the first node is 5 with the next field of address is 200, and next second node is with the data is 10, and then the second node is address field is null. So we have successfully inserted the two nodes. Now we are going to insert the third node. So in this third node case, okay, always we are accessing the pointer of head. That is, the head pointer is first connected with the first node, and then the insertion of second node, we are just using the head next, and then we are connecting the second node. Okay, if it is a two node, it's not a problem. We are using the head pointer, we can connect the first and second node. And next we are taking this third node. Now I am going to insert the third node in the already existing list. For this, as usual, you have to collect the structure for this node, new node using the malloc. The structure is created and collect the data from the user. The element also collected. So for this, now I'm going to use the third node. Wait, yeah, third node. So the third node data is some 15. The third node data is 15. Wait, data data is 15. Third node data. Third node data is 15, and then the third node address is 300. 300. Okay, so now we have created a node with the memory space along with the address. Okay, the address also created, the memory space also created. So now our node is ready. So as usual, if the we have to check, okay, after, okay, we have created a node and then we have to connect with the head node. So first we have to check whether the condition, if head is equal to null or not. If here, as per this case, the head is not null, already the head contains some value. If it is a first node case only, the head is initially null. But now we are inserting a third node case. So automatically this first case is false, if case is false. Now we have to go to the else part. So now head next equal to new node means this is okay. The third node is called as a new node. Okay, the head next means, so now this is the same head node. It's pointing to first node, and head next is already contains some second node address. 200 is available here. I'm assigning head next to the, I am using the same condition, head next of new node means, so it will be here, this will be replaced, 200 is replaced by 300. So these two nodes will be, okay, this node 2, okay, node 3 and node 3 and node 1 will be connected, but this node second is disconnected. Okay, to avoid that, okay, if we are accessing the all the node through the head pointer means we cannot retain the new nodes list. We can only retain the two nodes. Okay, to avoid that, we have to create another pointer, that is a temp pointer. So that you have to create here also, asterisk temp. So we have to insert the next pointer temp. Okay, so we have to create a temp pointer. So now this temp pointer we have to, okay, instead of accessing the head node, it's a fixed head node. So instead of the head node, we are more, okay, assign this head as a temp. We are going to create one alias for this head. So now that alias is called as temporary node. So that temp node pointer we are going to access all the node. Okay, so now that's why here we have used if head is equal to temp equal to new node. So temp is now called as a okay, head is now called as a temp node. Okay, so now now this is see, okay, always we are going to access the temp node. So for the second node insertion, instead of the head next equal to new node, we are going to use the temp next equal to new node. This is the temp node now. The head is called as a temp. Now this is a temp next field. The temp next equal to new node. The second node will be connected. Now we are attempting to inserting the third node. The same case. Already we have assigned head as a temp. Okay, the temp next equal to new node and the new node equal to temp. After insertion of this second node, this new node we named as the temp. Now this is the temporary node. Now I'm going to insert this third node. This will be called as a new node and this is a temp node. As usual, you can, okay, connect these two. This is the temp node. This temp node next is initially null. Now you can insert the temp node next. Here is empty. Now the new node address is 300. So that you can store into the temp next. So temp next equal to new node means these two will be connected. Then we have to assign this new node equal to again called as a temp. Likewise, in future, we want to insert the fourth node means now this is called as a temporary node and the fourth node is called as a new node. We can connect the temp next with the new node and the new node equal to temp. Likewise, we can insert the nodes one by one into the list. So this is the creation of list. Now we have successfully created the three elements in the linked list. Now I want to display all the elements of my list. For that, you have to, okay, if you want to continue to insert the nodes in the linked list means you have to use some choice. Okay, printf, do you want to continue either 0 or 1? So you have to get a choice from the user. So scanf percentage comma ampersand choice. If the user is willing to insert a new node means you can keep on insert. Otherwise, we can display the elements. For displaying also, so now, okay, after the third node insertion, now this third node is called as a temporary node. Okay, I want to print all the nodes. I want to print all the nodes. Okay, I want to print all the nodes. Okay, so in the okay, here all the nodes are available 1, 2, 3. I want to display all the values of the three nodes. For that, I'm again moving my temp pointer equal to head. So now the head is equal to temp means the temp pointer from third node to it will be moved to here. The first node, it points to the first node. So now I have to access all the elements. I have to print all the elements for that. So head is equal to temp means now this head is called as a temporary node. So we have to check whether the temp is not equal to null or not. So now this is temp node. This temp node is whether it is null or not. No, it is not a null because it contains a value of 5. Okay, so if it is not null means you have to print the temporary node data. So now the temp pointer is available in this node, and here it is not a null node, it contains some value, that is 5 is available. So print that temp node, temp of data. We cannot access the data directly through the reference, only we can access that by, that's why here temp of arrow operator data. Now next is, okay, if once you have printed this, I want to print the next. So for that you have to increment the temp pointer. So temp next, this is a temporary node. The next field of temp is now called as a temp. Now this temporary pointer is moved here. Now check again the condition whether temp is not a null. Yes, it is not a null. So we can print a data. And then again we have to move a temp pointer to the next node. So temp next equal to temp. Now the temp pointer is available here. It is not a null node. So you can print the value of this data, and again you can move a pointer to temp equal to temp next means here there is no node is available. The condition is here false. Temp next is null node. So we cannot print the values further. So this is the display operation. So in this example, we have created a 3 node and the same 3 will be displayed. So this is the way we have to create as well as display the linked list. So thank you. We will discuss the remaining, that is insertion at the beginning, insertion